Mendeleev gave his periodic table in 1869. His work was greatly appreciated, but there were some defects in his table due to which his table had to be discarded. Henry Moseley, an English physicist, was aware of these defects. He was aware of the problem of isotopes, shown in the Mendeleev's periodic table, the problem that silver and lithium were grouped together. They were not chemically similar. And also gold and platinum, having chemically similar properties, were placed wide apart in the periodic table. He was the first scientist to calculate the number of protons in any atom. Number of protons is the atomic number for an element. Henry Moseley was the first scientist to calculate the atomic number for any given element. He believed that atomic number is a more fundamental property of any element rather than its atomic mass. So he used atomic number to classify the elements in his table. This is the periodic table given by Henry Moseley. It's also known as the modern periodic table because this is the final accepted form of the periodic table today. It includes 118 elements that have been discovered so far. Let's compare it with Mendeleev's periodic table. In Mendeleev's periodic table, we see that the elements are arranged in increasing order of atomic mass. So if you'll observe, the change of atomic mass is not very gradual. Well, in case of the modern periodic table, the elements are arranged in increasing order of atomic number. So the change, that is 1, 2, 3, 4, 5, 6, and so on. It's very gradual. Further, let's see. The modern periodic table has 18 groups. Let's see how these 18 groups come from. In Mendeleev's periodic table, he had 8 groups. The first 7 groups were divided into A and B, and the last group, that is the 8th group, had 3 series of elements. So each subdivision in Mendeleev's periodic table was taken by Moseley as a separate group. So 7 into 2, 14, plus 3, that is 17 groups. So the modern periodic table has 17 groups. And this group of elements, that is the last group of elements, they were discovered after Mendeleev gave his periodic table. So they were accommodated by Moseley in his periodic table. These elements are also known as noble gases or inert gases, as they do not participate in any chemical reaction. This group is also known as group 0 because the inert gases do not participate in any chemical reaction. Okay. So here's how we get the 18 groups in the modern periodic table. Now the modern periodic table also has 7 periods. But in case of Mendeleev's periodic table, there were 6 periods. So the 7th period of elements, these elements were discovered after Mendeleev gave his table. So they were accommodated by Moseley in his modern periodic table. He arranged these elements in the increasing order of atomic number. If you'll see here, you see that the elements are also divided as A and B. This was also used in Mendeleev's periodic table. He had used A and B in the same groups. So Moseley separated the elements belonging to groups A and B. He placed the elements belonging to group B in the center. So as in Mendeleev's periodic table, zinc, cadmium, mercury, they belong to group 2B. Similarly, in the modern periodic table, zinc, cadmium, mercury belong to group 2B. Further, the 8th group, that is iron, cobalt, nickel, which does not have any subdivision. In the modern periodic table again, this group of elements, iron, cobalt, nickel, is in the group 8. So, do you see anything here? He had placed 1B and 2B towards the right and 3B, 4B towards the left. Why did he do so? Let's try to see. So if we see here, we have 1B, 2B, followed by 3A, 4A, and so on. So it's 1, 2, 3, 4, up till 8. Similarly here, it's 1A, 2A, followed by 3B, 4B, 5B, up till 8. So it's 1 to 8. Also, if you will see, 2A lies below 2, 3B lies below 3. Similarly, 1B lies below 11, 2B below 12, 3A below 13, and so on. So this is a very systematic arrangement of elements. So by arranging the elements in this manner, Henry Moseley was able to give a very well-organized periodic table. So the modern periodic table is an extension of Mendeleev's periodic table. It rectifies all the problems that were present in his table. Aren't you confused by these two series of elements which are not placed in the main periodic table? What is this line joining them? Let's see. So if this is the periodic table, half the part is moved away. We see that a series of elements lies behind La. And a series of elements lies behind AC. So if that part is brought back, we do not see those elements. So there was a series of elements behind La. La has an atomic number 57, and the element after it, HF, has atomic number 72. So the elements in between, that is 58 to 71, which lie behind lanthanum, are called Lanthanide series. To see them in a two-dimensional frame, they are placed separately in the periodic table. And the elements behind the actinium that we saw right now in the three-dimensional frame, that is from atomic number 90 to 103. This series of elements is known as the Actinide series. And this is the reason that these two series of elements are placed separately in the periodic table to make them visible in the two-dimensional frame. So this is the modern periodic table as we know today. What are the number of periods in the modern periodic table? Well, we have just seen that the modern periodic table has 18 groups. It has 7 periods. 6 periods were present in the Mendeleev's periodic table. Some elements were discovered after Mendeleev gave his periodic table that were accommodated by Moseley in his periodic table. So overall, the number of periods in the modern periodic table is 7. Okay. So atomic number for each element is unique. We know that when we change the number of neutrons, the atom becomes an isotope. When we change the number of electrons, the atom becomes an ion, a positive or a negative ion. What happens when we change the number of protons? Let's see. If we add 1 proton to lithium, it becomes beryllium. You add 1 proton to beryllium, it becomes boron. So as you change the number of protons, the element no longer remains the same. It becomes, or it changes into another element. So the atomic number, that is the number of protons for each element, is unique. And therefore, this was used as a property to classify the elements in the modern periodic table. Let me end this lecture by telling you an interesting fact about the periodic table. The only letter which is not present in the periodic table is letter J. You do not believe me? Well, you can check that out for yourself.